Hello, today we're going to look at when we use inference to make decisions, there's some errors that we can make in our conclusions. And these errors are not uh, are not mistakes per se, but they're errors in from the difference between our conclusion and what is actually true. Now there's two types of errors that we're concerned about. There's the type 1 error and the type 2 errors. A type 1 error is if we reject the null hypothesis, but the null is actually true. So what that means is if I have a null mean right here, and say my alternative hypothesis is less than, sometimes I'm going to get a point that lands over here, even when this is the true mean. In our interpretation, our conclusion will say we reject this null hypothesis and we have evidence that the mean is less than that. But that might not be true. In reality, it's possible that the null mean is actually true. The opposite is also true, which we call a type 2 error. If we fail to reject the null, but the null is actually false. So I'll show you what that means. So if I have a null hypothesis here, if I get it in this rejection area, I reject this null hypothesis. But let's say I get a point that's right here. At that spot, I fail to reject this null hypothesis, but it's possible that the mean is really less than our null. So in that case, we call that a type 2 error. Now, I'm going to give a more specific example. Hopefully it'll make more sense. But before we do that, let's talk about the truth in about the population. So here's a little graphical organizer to help you think about this. If you reject the null hypothesis, but the null is true, that means if this null is true, I get a point out here, I reject it, then that's called a type 1 error. If we reject the null hypothesis and the alternative hypothesis is true, we made the correct decision. We did things right. Now, to fail to reject the null, that means our point wasn't here. Maybe our point was over here. Over here, we failed to reject the null. If the null hypothesis is true, everything is all right. That's a correct decision. But if the alternative hypothesis is true, if it is really less than, if the true mean is less than our null, then we made a type 2 error. Here's our example. We're going back to the old, that first thing that we did, paramedics. The city manager wanted to test that the mean paramedic time was less than 6.7 minutes. So let's think about type 1 and type 2 errors. Now, a type 1 error would mean that if this is 6.7 and this is our rejection area, we have a point over here, but the mean really is 6.7. So I'm just going to type a little bit more clear than my actual writing. Maybe I'll type in red. So type 1 error is when we get a sample in that shows that paramedic response times decreased. But the true mean is really still 6.7. So that's what the type 1 error is. We had evidence that they decreased at times, but the mean was really 6.7. And what are the possible consequences? So you could say something like a consequence could be that the city manager is happy with the results and um, and doesn't continue to push for reduced times. So maybe the city manager just kind of gives up or stops working with them and says, hey, you guys did much better. We're all done working. Now, a type 2 error is a little bit different. A type 2 error is what, if we get it over here, get our point, I'll do this one in red, over here. So what that would mean is we fail to reject the null, but the null is actually, but the null is wrong. So a type 2 error in this situation, I'll color this red again, is we don't have evidence that the mean time decreased, but but it really did. We just didn't have evidence that it decreased, but it really did decrease. So consequence is that the city manager implements a new program to reduce response time when they really don't need it. So the city manager might come back and be mad that that they that they're not improving their times, but they actually have improved their times. So so if the city manager wants to test at a 5% level, for probability of a type 1 error is 5%. Because if you have your, that's a bad normal distribution. Hopefully you can deal with it. So if this line is right here, that's our rejection area. It happens to be in here 5% of the time if our alpha is 0.05. So our rule is that the significance level alpha for any fixed level test is always going to be the type 1 error. Now we're going to do one more example and then give some for you to do. This is the feasibility of constructing a profitable windmill. They need the windmill to produce winds greater than 20 miles an hour. If it's at 20 miles an hour or less, then it's just not going to be profitable. So this is our situation. So let's test and try to find type 1 and type 2 errors. So for our type 1 error would be, just to draw it out real quick before we get into it, we want it to be on the top end. So a type 1 error, we reject the null hypothesis when the null is actually true. So our null was 20. So how we'd write this out is our type 1 error is we have evidence that the winds are greater than 20 miles per hour, but they really aren't. Type 2 error would be, I'll do that in a different color. Say green. I get a point right there. So maybe I should type this in green. So what that is we don't have evidence that the winds are greater than 20 miles an hour, but they really are. Now a common question that is asked here is which one is worse, type 1 or type 2 error? And typically the answer depends on the perspective that you're looking at it from. If you're a company setting up wind turbines and you want to see if there's a good spot, a type 1 error would be a huge financial mistake. If we got a type 1 error and we got a dot out here where we reject the null hypothesis, uh, then you build a windmill in an area that is not feasible. And for the company, if you uh, if you don't have evidence that it's greater than 20 miles an hour, then you just skip that spot and you go to somewhere else. And so even if it is a, a profitable place, the company's not wasting money on a type 2 error. So in this case, if you're a company, your type 1 error is much worse. So typically, when that happens, when people decide the type 1 error is worse, that helps them change their alpha level to a level that is more tolerable. So if they understand that this is going to be a very bad problem if they have a type 1 error, then they'll start the study reducing the alpha level to 0.1 or, or 0.01, 0.001, something that would create a really low type 1 error. Oh, yeah, which is worse. I answered those questions without realizing those are on the next slide. So in this situation, a type 1 error would be worse for the company, and alpha that would be appropriate would be type 01 or type 001. Then the company knows for certain, or have a higher certainty, that it is going to be uh, a good place. Now, if the alpha level is 0.01, find the probability of type 1 error, 0.01, and we're done. Hopefully that helps with on your own.